Y'all didn't seem to have too much trouble with Chapter 13, Tab 3, but we didn't get a chance to talk it through in class. So let's make sure we do that now. So you have the given information. I haven't included in my screencast just because it didn't fit. But remember that they each would make $500 at the safe job. They value safety at 120. If they both make the same amount, there's no status due to that positional externality that isn't a factor. So they end up 500 salary, 100 from safety, 120 from safety. They total 620 each. That's not the neatest writing, but anyway, you get the idea. If they both take the risky job, again, there's no status change, but then they're making each 600, or they're making 600 each, and that's an easy one. Slightly harder, as I monitored your work through the class, is what happens when, say, Al is at the safe job and Tom is at the risky job. Let's figure that out. And then, of course, once we figured that out, it's symmetric, so we figured that out too. But let's go forward. So if Al takes the risky job, he loses the safety. But on the other hand, he makes $600, plus he gets that $100 bump by being the richer of the two. Being relatively richer confers the status gain equal to 100. So he makes 600 in salary, gets this positive 100 bump in status, so he totals at 700. Then some of you were netting off, like subtracting 120 for not having safety, and no, if he doesn't get the benefit of safety, he has 0, right? And then finally, Al makes 500 at the safe job, gets 120 from being safe, but then loses 100 because he's now relatively poorer. So his net there is 520. And then it's a symmetric game, as I said before, so if it were the other way around, it would be, these payoffs would be reversed. All right, would they choose optimally between the two jobs? Well, we see that, and this is a nice review going into the final, we see that this is a prisoner's dilemma, and let's just look at it from Al's perspective. If Al thinks Tom is going to take the safe job, Al could take a safe job and make 620, or he could take a risky job and make 700. So he has he would take the risky job if he thinks Al is going to take the safe job. Well, what if he thinks Tom is going to take the safe job? So what if he thinks Tom is going to take the risky job? Well, Al could take a safe job and make 520, or take the risky job and make 600. And again, we see that it's a risky job. Well, it's a symmetric game, so that we know that Tom would make the same pair of choices, and lo and behold, each has a dominant strategy to take the risky job. This is our classic prisoner's dilemma. They end up both taking the risky job. No, prisoner's dilemma, Nash equilibrium is not mutually best outcome. And at this point in the semester, we can just invoke that regularity of prisoner's dilemma without explaining it any more than that. So the mutually best outcome we can see is where, actually let's just check that. I didn't check that. I should have, but I was going to say just unqualifiedly that the mutually best outcome is where they're both at the safe job, and let's just verify that it is, now that I look at it, but it only by accident. I didn't think about that when I made up the game. They end up at a combined 1240 here and just 1200 here. What I didn't check, what I should have checked, is what if one's at the risky job and one's at the safe job. There they get a combined income of 1220, and let's say that combined income, just because I made the status be worth 120 or something. Let's say that combined income at the risky safe outcome were such that the total payoff to the pair of them was more than 1,240. Well, then there would be a potential for side payments, and the answer to 3, we'll see in a moment, would change. But got lucky there. I didn't double check, but I got it right that the mutually best outcome is safe, which is what I had intended when I crafted this game. All right, number 3. If Tom and Al could negotiate binding agreements with one another at no cost, which job would each choose? There, they both would choose the safe job. And maybe the form of the binding agreement is that they elect politicians that enact that rule. And there we see that regulation as the solution to this positional arms race. And that's certainly Frank's point in setting this type of problem up. And then finally, if negotiation for whatever reason were impractical and putting a government regulation in place would cost $50 per week that they have to pay themselves, then there wouldn't be a potential gain for government action, because there the moving everybody to the safe job would result in payoffs, all else equal, of 620 each, 1,240 total. But the fact that costs $50 and that Tom and Al have to pay that $50 brings the system down to $1,190, which is less than what they'd get if they both stayed in this risky job. A lot of times, just looking ahead to chapter 14 issues, a lot of times we're in the situation of being able to vote for regulation that somebody else pays for, and then that not to say that's necessarily a bad thing, but if it's the case that enforcement costs outweigh the benefits, but that somebody else is paying the enforcement costs, well, then we have a problem of government, that you have a system where actions are taken where the benefits are less than the costs, but they're nevertheless taken because of the way costs and benefits are distributed. Well, that can be a problem. That alone doesn't make us conclude it's a problem, although it gets us pretty darn close. And that's one of the problems of government. And it's not to say we dismantle government, but as we think about how government is to act, we have to be aware that danger exists.
Made with Doodlecast Pro.